second solution scheme to turn our red arrows black. So again, now we go back to the free body diagram with three unknowns. So again, we're just going to apply these equations of equilibrium in a slightly different manner, and we will find out that we're going to end up with the same answer in the end. So if I spin a moment at point B to start, so I'm going to begin right here. That's going to give me the ability to solve for F3. So if I do that, I end up with, again, the applied moment, which is the 25 Newton meters, right, which happens to be sitting at point B. And then I end up with plus F3 times 12. Numerically, I end up with a negative answer for F3, meaning that F3 is actually going up. Go ahead and now recreate our solved free body diagram. We've turned one red arrow black, so this is what our free body diagram now currently looks like. Right, and our scheme now is going to ask us to sum moments at point A. So I'm going to do that again all the way out here, giving me the ability to solve for F1. Essentially at this point, what I want to do is pick a point that is on the line of action of F2 and not on the line of action of F1. And anything that meets that criteria would work. And if I solve that equation, I again end up with F1 equals plus 2.92. And again, the answer numerically relates back to the free body diagram. So that means that F1 is drawn in the correct direction. So if we continue now, we've turned another arrow black. And now instead of summing forces in the X direction to solve for F2, just for demonstration purposes, I'm going to sum moments 2 meters above point C. So I'm just going to create a point right here. And that point is going to be 2 meters. Again, I can sum moments at any location, just like I can sum forces in any direction. And so there's nothing special about doing it off the beam. And again, here, by doing it off the beam, I have a point that is not on the line of action of F2. And that's really my criteria. Any point off the beam would work. So if I sum those moments at point C, I'm going to end up with a pretty long equation here. Obviously more work than summing forces in the X direction. And I'm going to have a contribution from the applied moment. I'm going to have a contribution from the 5 newtons, right, the component of the applied load in the vertical direction. I'm going to have a contribution from the reaction that I've solved for. I'm also going to have a contribution from the horizontal component of the applied force. It's perpendicular distance, right, being 2 meters. And then another contribution from F2. And that will give me then one equation, one unknown. I find that F2 numerically is negative, which means that it's going in the other direction.